Electricity and circuits. Learning objectives. Electric cell. Electric bulb. Electric circuit. Electric switch. Electric conductors and insulators. Importance of conductors and insulators. We are all familiar with electricity. It is a form of energy. In modern society, it is the most important part of life. Can you imagine life without electric lamps, fans, radio, television, refrigerators and computer or vehicles? Electricity makes it possible to light everywhere. Do you know another source of light energy? In your house, a torch is sometimes used for providing light. When you switch it on, the torch bulb glows and gives light. Have you seen a torch from inside? Let us see, where does the torch get its electricity from? Open the torch cover from the front or the back. You will see inside two cylindrical objects. What are these? These are electric cells. Electric cells provide the electricity to the bulb in the torch. Thus, the electric cell is another source of electricity. Let us study about the electric cell. A glowing torch. Electric cell. You have already seen, the electric cell is also used in clocks, calculators, remote transistor radios, cameras and other devices. Electric cells are made of different sizes in accordance to a particular device. Some of these cells are shown in the figure. Pencil cell. Metal cap. Metal disc. Button cell. Electric cell. Insulation. Zinc electrode. Carbon electrode. Carbon. Have you ever carefully noticed an electric cell? You will find a positive, plus, sign and a negative, minus, sign printed on the electric cell. These signs indicate the terminals, ends, of the cell. The metal cap is the positive terminal of the electric cell. The metal disc is the negative terminal. All electric cells have two terminals, a positive terminal and a negative terminal. These terminals are clearly marked, plus, positive and, minus, negative. Have you noticed inside a torch, how are cells arranged inside it? Let us perform an activity to learn the arrangement of cells in a torch. Activity 13.1. Take a torch which has more than one cell. Open the cover of the torch and take out electric cells from it. Keep the cells in different arrangement and what happens when you switch it on? The torch bulb does not glow. Again open the torch and take out cells from it. Now arrange the cells as shown in the figure and insert the cells in this arrangement. When the torch is switched on, it gives light. Now, you have learnt that the negative terminal of the first cell is joined to the positive terminal of the second cell and so on. This combination of cells is known as a battery. Let us perform another activity. What can you see inside the cell? Activity 13.2. Take an old used cell. First take off the cardboard wrapping and cut it from one side. You will find that a cylindrical container is made of the metal zinc. The container also acts as the negative terminal. A carbon rod with brass cap acts as the positive electrode. It is surrounded by a black powder, a mixture of manganese dioxide and carbon particles. Between this mixture and the zinc container is a thick paste of ammonium chloride which forms the electrolyte. This electric cell is known as dry cell. It produces electricity from the chemicals stored inside it. When the chemicals in the electric cell are used, the electric cell cannot be used anymore. Many other types of cells are available. These are 1. Batteries. In everyday life, cells are almost always said batteries, but this is scientifically incorrect. As you know, a battery is made of two or more cells joined together. The car battery used in a car is big and heavy. It is normally made up of 6 cells which use chemicals to produce electricity. When these chemicals are used up, the battery stops working. Car battery. 2. Button cells. These are very small, about the size of button, and are used in calculators, wristwatches, toys, etc. The plates of these cells are made from the compounds of nickel and cadmium. Button cell. 3. Solar cells. Solar cells make electricity when sunlight falls on them. The cells change some of the sun's energy into electrical energy. They are ideal for places where there is plenty of sunlight but no electricity supply, such as in orbiting space satellites. It is used in watches, calculators and satellites. Solar cell. Electric bulb. Observe a bulb carefully. You will see that inside the glass cover is a very thin wire made into a coil. This tiny coiled wire is called filament. This filament is connected making V-shape called supporting wires. One wire is connected to the metal casting at the side of the bulb and other wire is connected to the metal tip at the bottom of the bulb. When the electric current passes through the filament of the bulb through wire, it glows and produces light. An electric bulb. Inert gas vacuum. Glass bulb. Base cap. Metal filament wire. Glass support. Activity 13.3. You will need an electric cell, a bulb, 2 plastic-coated copper wires. Now connect one copper wire to one of the electric cells and second copper wire to the other end of the electric cell. Use a tape to fix the end of wire on each terminal as shown in figure. Now take a bulb and connect one end of the wire to the cylindrical metal base of the bulb. Fix another end of copper wire to the base of bulb. Use tape to fix the wires to the bulb. Electric current always flows from the positive terminal to the negative terminal of a cell. Now, connect the bulb to the cell in 6 different ways as shown in diagram. Observe carefully the arrangement in which the bulb lights up. You will see that bulb glows in figure 1. In this arrangement, a continuous path starts from positive terminal to negative terminal and hence the bulb glows. In figures 2 and 3, the path of electricity is not continuous, so that current does not flow from positive to negative terminal. Hence the bulb does not glow. In figures 4, 5 and 6, the end of the both wires of the bulb is attached at same terminal. In such arrangement, no current flows and hence the bulb does not glow. Electric circuit. An electric circuit means the path from positive terminal of an electric cell through the bulb and to negative terminal of electric cell. The arrangement of a complete path of figure ahead shows an electric circuit. You will notice in these paths that the 2 terminals of the electric cell is fixed to 2 terminals of the bulb. This electric circuit is also called closed electric circuit. Look at the following figures. You will find that electric circuit is broken at any point. Such an electric circuit is known as open electric circuit. In closed electric circuit, the electric current flows from the positive terminal of the cell to the negative terminal through the filament of the bulb. The direction of current in closed circuit is shown in figure. Closed circuit. Source. Load. Conductors. Control. Open circuit. Source. Load. Conductors. Control. Fused electric bulb. Sometimes a bulb does not glow even if it is connected correctly. Observe electric circuit carefully. You will notice that filament of bulb is broken. Due to this, the path of the current between the terminals of electric cell will break. Hence no current flows in the electric circuit and bulb does not glow. Such a bulb is called fused bulb. Can you make a torch yourself? Let us try make to a torch. Activity 13.4. Take a torch bulb, an electric cell, a few pieces of electric wire with bare end and cello tape. Fix pieces of two wire X and Y to the two connections in bulb socket. Fix the bare end of wire X to the positive terminal of the cell. Now connect a third piece of wire Z to the negative terminal of the cell. Now bring the end of the wire Y to the end of wire Z. You will notice that the bulb is glowing. Keep the wire Y away from the end of wire Z. Does the bulb stop glowing now? A bulb with two wire X and Y. Wire Y. Torch bulb. Wire X. Electric cell. Connect wire X with positive terminal of cell. Wire Y. Torch bulb. Wire X. Electric cell. Connect third wire Z with electric cell. Wire Y. Torch bulb. Wire X. Electric cell. Wire Z. A circuit. Wire Y. Torch bulb. Wire X. Electric cell. Wire Z. Y to the end of the wire Z. Turn off switch by removing the end of the wire Y from the wire Z. Electric switch. In activity 13.4, we can switch on or off by touching or removing the ends of two wires. This acts as a switch, but it is not a convenient switch. Thus, a switch is an electrical device which can be used to turn electric circuit on or off. Now you will learn to make another simple and easier switch to use in homemade torch. Activity 13.5. To make a simple electric switch, you will need the following items: a small sheet of cardboard or thermocol, two drawing pins, a safety pin, a torch bulb, an electric cell, few pieces of wire with bare ends. Again, make an electric torch which you have made in previous activity. Take a drawing pin and wrap the bare end of wire Y around its pin. Now insert it into the loop at the one end of the safety pin and fix it on the sheet. Make sure that the safety pin can just turn around. Now wrap the bare end of wire Z around second drawing pin. Fix it on the sheet in a way that the safety pin can easily touch it. Now connect the safety pin with the head of drawing pin as shown in figure. Now make a circuit by connecting an electric cell and a bulb with this switch as shown in figure. Rotate the safety pin so that is free and touches the other drawing pin. What do you see? You will see that bulb lights up. This positive switch is set to be on. If we do not touch safety pin with the drawing pin, you will see that bulb does not glow. This is because the electric circuit is broken. Now it acts as off switched. Switch in off position. Thermocol sheet. Drawing pin. Wire Y. Safety pin. Wire. Gap. Switch in on position. Z. Safety pin. No gap. Electric conductors. In previous activity you have noticed that we have used metals wires to pass electricity in a circuit. Thus, the materials that allow electric current to pass through them are called conductors. When the conductor is connected to a dry cell by means of copper wires, these charges will flow in one direction only. So, copper wires are good conductors of electricity. Inside the conductor are tiny particles called charges. Thus, the rate of flow of charges is called flowing of electric current. Examples: all metals are good conductors of electricity. 2. Graphite and carbon gases are good conductors of electricity. 3. Impure water is a good conductor of electricity. Let us perform an activity to prove that metal conducts electricity. Activity 13.6. Arrange the electric circuit which you used in activity 13.4. Loosen the end of the copper wire Y from the end of copper wire Z. Touch the bare ends of wire Y and Z with a steel spoon. As soon as steel spoon is touched to bare wire, the circuit gets completed and the bulb glows brightly. Thus, Metal is a good conductor of electricity. Electric cell. Wire Y. Torch bulb. Wire X. Wire Z. Steel spoon. Insulators. Those materials which do not allow electric current to pass through them are called insulators. Examples: plastics, rubber, wood, glass, polythene, PVC. Let us perform an activity that rubber is an insulator. Activity 13.7. Recall activity 13.6 in which you made an electric circuit. Remove the steel spoon from the electric circuit. Now touch the bare end of wire to an eraser. You will notice that bulb does not glow. Thus, rubber is an insulator that does not allow the electric current to flow. Electric cell. Torch bulb. Wire X. Wire Z. Rubber eraser. Both conductors and insulators are important in using electric devices. We use conductors to make electric devices such as an electric bulb, a fan, a washing machine, a cooler, etc. But we cannot use bare wire as this would be dangerous. Therefore, we cover these wires with an insulator such as plastic. In houses, you would also have noticed that the outer coverings of switches, regulators of fans, plugs, sockets, etc. are covered with plastic. Iron press. Importance of conductors and insulators. We know that conductors and insulators are equally important for us because they are both useful in their own ways. Conductors are used to carry electricity, or electric current. For example, electricity is carried in our homes by copper wires, or aluminium wires, because copper and aluminium are conductors of electricity. The electricity used in our homes can be dangerous. A person will get an electric shock if he touches a bare wire carrying electricity, or electric current. It can even kill a person. Insulators are used for safety. Insulators protect us from getting electric shocks. Insulators allow us to handle current-carrying wires, switches, plugs, sockets, and other electrical appliances safely. See figure. For example, the electric wires are covered with insulators like plastic or rubber. Being an insulator, plastic or rubber covering does not conduct electricity flowing through the wire into our body when we touch it. So, if we happen to touch a current-carrying wire covered properly with plastic or rubber insulation, we will not get an electric shock. Thus, the plastic or rubber covering on the wires protects us from the electricity that is flowing through the wires. In other words, the plastic insulation makes the electric wires safe to touch. Just like electric wires, electric switches, and electric plugs, etc., are also covered with insulator material like plastic to protect us from the electricity passing through them. The knowledge about the conducting or insulating properties of various materials is made use of in choosing materials for making electrical components and appliances like electric wires, electric switches, electric plugs, electric sockets, electric iron, toaster and ovens, etc. Insulator, like plastic, make electric wires, switches, and plugs, etc., safe to touch. Electric switch, plastic case. Electric box, plastic cover. Electric plug, plastic case. Electric wire, plastic covering. 1. Those parts of an electrical component or appliance through which electric current has to pass are made of conductors like metals or metal alloys. 2. Those parts of an electrical component or appliance which are touched by us while handling are made of insulators like plastic, rubber or wood, etc. so that current may not pass through them. The electric wires are made of metals like copper and aluminium because they are conductors, but the outer covering of electric wires is made of plastic or rubber because it is an insulator. See figure ahead. Similarly, The pins of an electric plug are made of metal, which is a conductor, but the outer case is made of plastic, which is an insulator. See figure B. The inner parts of electric switches and electric sockets are made of metal, conductor, but their outer case is made of plastic, insulator. A. The electric wires are made of copper, conductor. The covering is made of plastic, insulator. Copper wire, conductor. Plastic cover, insulator. B. The pins of electric plug are made of metal, conductor. The plug case is made of plastic, insulator. Metal pins, conductor. Plastic cover, insulator. The heating element of an electric iron is made of a metal alloy, which is a conductor. But this heating element is enclosed in a sheet of mica, which is an insulator. The handle and top part of an electric iron, which we touch, are made of plastic, which is also an insulator. Rubber, plastics and ceramics are often used to protect us from the dangers of electricity because they are good insulators. For example, electricians wear rubber hand gloves while handling naked electric wires because rubber is a good insulator and protects them from electric shocks. See figure C. The handles of tools like screwdrivers and pliers used by electricians for repair work usually have plastic or rubber covers on them. This is because plastic and rubber are insulators which protect the electrician from electric shocks when he's handling current-carrying electrical appliances. It is advisable to wear rubber-soled shoes or rubber chappals while operating electrical appliances. This is because rubber is an insulator which will protect us from electric shocks in case there is a leakage of electric current from the appliance. C. Electricians wear rubber gloves to protect themselves from electric shocks. Q keywords. Battery. A combination of two or more electric cells. Current. The rate of flow of electric charges. Circuit. A closed path for the flow of electric current. Filament. A very thin coil of metal in a bulb. Conductor. A substance that allows electric current to flow through it. Insulator. A substance that does not allow electric current to flow through it. Summary. Electric current is the flow of charges through a conductor. Electric cell is another source of light. Electricity is produced from the chemicals within the electric cell. All electric cells have two terminals, a positive terminal and a negative terminal. The combination of two or more cells is called a battery. The path along which an electric current can flow is called an electric circuit. A circuit can be opened or closed with the help of a switch. The direction of electric current is always from positive terminal to negative terminal. Switches are electric devices that are used to turn electric circuit on or off. A substance that allows electric current to flow through it is a conductor of electricity. An insulator does not allow electric current to flow through it.